and you see the plot with the points with polar coordinates.
Mhm.
I I don't. I mean, I can't really tell you what could or couldn't be on there. Um, so we should probably do a couple of each one, I guess. Do you have a is that okay?
Um, on the, midterm 2, which was, the one where she tested this type of question, the question stem was like, take y equals 3x squared plus x and convert to polar form.
Say that one more time. Y equals 3x squared plus x.
Yes, and then
And
convert it to polar form.
okay. So those are more like 24.
Okay.
Let me snip those in. Sorry, there's so much here. If we start in the wrong place, we'll just waste all the time. So just give us. This is what you just.
Oh, yeah, totally.
These
Yeah,
are
I just wanted to
just
have that whole doc there.
okay. So any of these would be okay to look at.
Yes.
Okay. So the relationship x equals r cosine theta, y equals r sine theta. Hopefully you've seen that.
Mhm.
Tangent theta equals y over x. So for example, in A, you're going to take these substitutions on the right here, and you're going to put them in. So it's r cosine theta squared, because that's x squared, plus r sine theta squared, that's y squared, equals 4. Okay. And you're essentially done. I mean, here it's a matching thing. So sometimes you solve for r, like if it's possible or reasonable. And that's where you have to have a little bit of experience here. So on the left here, this is r squared cosine squared theta plus r squared sine squared theta equals 4. And if you factor in r squared, you get r squared uh, cosine squared theta plus sine squared theta
Mhm.
equals 4. And you're supposed to know this identity as well. Sine squared theta plus cosine squared theta equals 1. So this right
Mhm.
here is equal to 1. So it's r squared equals 4. And then uh, you can do a bit more. You take the square root of both sides. R equals 2 for that. You tend to only use positive r's.
Okay.
Um,
And then from there, how do you get it into like a polar equation?
this is a polar equation. That's maybe what's unclear.
Oh,
That is a polar equation. It's so polar equations are in terms of theta, but just like lines or any functions, you don't have to necessarily have thetas or x's on the right. So this equals 2. This is good
wow.
enough for that.
Okay. Awesome.
Uh,
Okay, thank
okay.
you.
Maybe do the last one there, because it's pretty straightforward there. Letter D. Um, it's x plus y equals 4. Okay, and uh, and so here you would type in, or you would substitute r cosine theta for x plus r sine theta for y equals 4. And I mentioned you're generally solving for r. Okay, so there's an r here and r here, and this is more common. You factor r out, you get cosine theta plus sine theta equals 4, and then you divide both sides by this thing here. This time it doesn't turn into 1. It just is it's just what you see there. It's cosine theta plus sine theta, and this is probably more of what you were expecting in terms of
Mhm.
like your function. It's got thetas on the right, variables on the right. You'll notice that letter double I on the right does not solve for R. Sometimes they don't, or this book didn't.
Oh, okay. Okay, that makes sense. Thank
So
you.
I initially thought you were going to ask us to do something from 11.1, a page 515, which is the parametric, which often, if you're first time student this, you might not see that. That's the like the 7 through 18 on 615.
Oh, okay.
Um,
Yeah, I also need help with parametric equations, so that would be good as well.
okay. Would you like to go there next? Was that the next thing to work on? It's up to you.
Yeah, that sounds good.
Okay. All right, so I'm gonna grab just a grouping of questions here. So if you're okay with this, I think I'll do like 8 maybe, or 10's not great but could be done. 12's good. Any of
Okay,
those
that
stand
sounds
out
good.
to you?
Not particularly.
Okay, so 8 is x equals t to the minus 1 power, and that can be rewritten as 1 over t. Y is t to the minus 2 power, or y is equal to 1 over t squared. So what you generally do, that doesn't work all the time, but generally you take the one for x and you solve for t.
Mhm.
You're going to use substitution from systems of equations. So when you solve this for t, you end up getting t equals 1 over x. Okay. And then this is what you take and move into this other equation, because your goal is to write y equals something with x in it on the right,
Right.
just like we did before. So that's why you solve for t, because generally y is a function of t currently. So we can write this way: 1 over x squared, like that. So this becomes 1 over x squared, which becomes just x squared.
Okay.
So 12 is very much
And
like
then
this. Go ahead. Sorry.
you're like, that's just the answer, like y
That's
equals
it.
x squared.
You're done. Yeah, right there.
Okay.
So 12 is like this one. We don't need to do this, but it's like 8. So you can look at that. But let's look at 10. 10 is different. X equals t squared. Y equals t cubed plus 1. So in standardized testing, you become accustomed to this idea that you don't always solve for thing. You solve for the thing that you need in the next part of the problem. So I don't really need this to be t. I need this to be t cubed. So how do I make
Mhm.
this into a cube? Well, you raise it to the 3/2 power, of course. And if you're going to raise the right side to the 3/2 power, you raise the left side to the 3/2 power. So it's not obvious, and that's why I'm doing this one. The right hand side becomes t cubed, and the left hand side becomes 3/2. So you're solving for t cubed instead of t, because you're going to take this and put it into there. So your t
Okay.
cubed is all
That
of
makes sense.
this. So this becomes y equals x to the 3/2 plus 1. Now you might be asking, well, can't I just take a square root here? Yes, you can. There are problems though where you can't get t exactly by itself. You have to get it into the form that it wants. There. So
Okay.
like
Can we
11.
try she gave us kind of a weird one on a test. Sorry, I should have scanned this in, but I forgot. Um, it's x equals 2 cosine of t, and then the other equation is y equals 2 cosine squared of t.
Okay, and what are you
And then
supposed
she
to?
said eliminate the parameter.
Okay. Right. So we know that we know like sine squared t plus cosine squared t equals 1. That would be
Mhm.
one possibility. There's some formulas for cosine squared t that I mean, maybe your instructor thinks that they're reasonable. Let me pull one up here for you. So cosine. So these are like on the right. Here's what you would have in a reference sheet. So the cosine of 2t equals 2 cosine squared t minus 1.
Right.
Okay.
Okay.
So I'm not sure I'm going with some of this yet, but um, we can do some things with this. We can also do.
On the test she said that like on my comments she said that she wanted me to solve it with inverse functions.
Wow. Okay. So like here, t is equal to, so on the left side here, t is equal to the cosine inverse of x over 2. Okay, so that's and then this would go over here, which is really weird, but we can do this. So
Okay.
another thing here is let me just rewrite this. I don't know how much more time I spend on this, but let's say cosine t equals x over 2. So you can draw a triangle. There's t, and the cosine of t is x over 2. So this becomes the oh, I see. Okay, that is what your instructor wanted to do here. So your instructor wanted you to get this, and then you're substituting for cosine t over on the right here. So y equals 2, and this is cosine t squared, like this. These are exactly the same, but they're written slightly differently. Cosine t is x over 2, 2 times x over 2 squared. I don't think you need to do any inverse stuff on this. Um,
Oh, that does not look bad at all.
yeah,
Okay.
it actually isn't. And it's kind of that point I was making about how it's kind of like you don't always have to solve for the variable. So I solved for the variable here, but that wasn't useful. If you solve for cosine t, because you're substituting it on the right, so it's almost like a matching thing. Like, do you see something that matches? And
Oh,
and then you get down here and you're like, oh, it's just x squared over 2.
okay. That makes sense. Yeah. Okay.
Is that
That seems pretty
is
simple.
that okay? So if that's satisfactory, what can we work on next to help you?
Can we do one where it's like take the rectangular point and then find the polar coordinates?
Sure. So let me
Yeah.
go up to the top here because I think I had some of those right here.
Wow.
Okay, so like for example, um, let's do like b here. Is
Okay.
that okay? 3 common square 3.
That sounds
Okay,
good.
so we're saying that x is 3 and y is square root 3. So we're doing 3b. Okay, and we need some things to work with. We know that r is equal to x squared plus y squared. R squared is equal to x squared plus y squared. So that's I think first thing you do. So r is equal to um, r squared is 3 squared plus square root of 3 squared. So that's 9 plus 3. So r squared. So r equals the square root of 12. Square root of 12 reduces to 2 square root of 3.
Hmm.
So there's two things we're trying to find. We're trying to find r. We're trying to find theta. So we got one of them. Theta, well, tangent of theta is y over x. So tangent of theta is square root of 3 over 3. So if you've got a unit circle, if you know your unit circle, you're trying to figure out like where does this happen. And I don't care if you look. This happens at pi over 3. This angle is pi over 3. This is just a unit circle. Look up. I can cover that if you need to. But what you're looking for is square root 3 over 2 over 1/2. And that this sort of back reduces to that value there.
Okay.
So there's two equations you need when you're doing
Mhm.
this, and the first one's usually straightforward. It's like just square square squared. Okay, done that for a couple of years now. The other one's a little harder because you have to know your unit circle. You have to know where that potentially is on the unit circle.
Right. Okay. Can scratch here. Okay. Okay. Yeah. And even if I can't do the unit circle part, I'll have gotten it far enough that I get the majority of the points.
Yeah, you've crafted a new term for me, those pity points, which I didn't even know was such a thing. So, uh,
Yeah.
well done. Do you want us to do one more of these?
It on the test it said find all 4 polar coordinates. So what's the deal with that?
All right, that's where it's a little tricky. So one of the ordered pairs here is 2 square root 3 comma pi over 3.
Mhm.
Okay, so this one. So to be clear, here's what's happening: is there's one circle that we're using, and it's this one is you go pi over 3, so you rotate first, and then you go out 2 square root 3. Okay, so we have to figure out how
Right.
to get to that point. Okay, so the other way, the first sort of like I think more obvious way is to go backwards. Just go backwards this direction. Okay, so how far backwards are you going? Well, it's 2 pi minus that, so it ends up being 5 pi over 3,
Mhm.
and you're still going 2 square root 3. So because you it's like rotating your body one way, and then you rotate your body the other way, and then you just take a step.
Okay, that
Is
makes
that okay?
sense.
Okay. Now the other two are more. They're hopefully the analogies I make are good for these, but in the other one, we're we're actually going. We actually have to spin to there, and then we take a step backwards because we still got to get to this point. So like, how do we get to here? What's that angle?
Oh, pi over 3
Plus
plus
pi.
pi.
Yes, 4 pi over 3.
Okay.
And
And then you have to do negative
right,
2 pi.
because it's almost like
Oh,
it's almost like you're stepping backwards. I don't know. That's where the analogy kind of falls apart a little bit, but um, it's a rotation and then a step. And imagine you could step forwards or step backwards.
yeah. I
And
think
then
the analogy still
okay,
works.
okay. Sometimes I'm not sure. Then you go this way on that one, and it's
Pi
two
minus.
yeah two.
Okay.
It's pi minus that, and then it's a step backwards. So some things that you can always take away from this is that there's always two that are the same and two that are the same on the r side, on the radius. The angles
Okay.
could be the same in some cases, but very unlikely. Usually they're all four different.
Okay, that's not horrible.
I would draw a picture. I think that helps a lot. So if this is clear, I do have to ask you just to make sure we cover things like are you okay going the other direction, going from polar to rectangular?
Um, yeah, let's try one of those. Let's try one of
Okay,
those.
so 6b says 3. It says theta is what, I can't remember, 6 comma 3 pi over 4. So this is r and this is theta. Let me get to where we got this. So there's two. I think this way is going better because x is r cosine theta and y is r sine theta. So x is 6
Mhm.
cosine 3 pi over 4. Y is 6 sine 3 pi over 4. The only
Okay.
challenge here after you know these formulas is like, do you know what those are at the unit circle? In this case, this is minus square root 2 over 2, and this one is square root 2 over 2, positive. Okay, and then just reducing them, right? So it's minus 3 square root 2, 3 square root 2, and that's an ordered pair. That's your x. That's your x and your y. A lot of equations.
I get 2 sheets of paper for this one, so
Okay.
that's good.
I hope you've seen some improvements since we've been working together. That's my goal for you, is to see your grade improve, and I hope that's happening.
Definitely. I haven't gotten a grade below an A on the after the curve on any of the math tests, and I definitely would not have gotten that without you. So,
Great,
thank
great.
you.
Excellent. Well, you're doing all the hard work, so never forget that. Where do you want to go from here? We've done some polar, we've done some parametric problems.
Can we do some derivatives?
Sure. I'm looking back at the I don't see any derivatives on this list.
Let's see.
There's limits. There's the difference quotient, which kind of is derivative, but not really. You shouldn't beat a
Yeah,
derivative.
it might be that. She has to do a lot of f prime x things.
Okay. So are we talking about like page, I don't know, 125?
Here, let's see. Yes, that. She called them derivatives in class, so I wasn't sure.
They are, but there's the which questions? 3, 3, 4, 5, 6? Any of those?
She said to ignore like the different equations and just do the difference quotient.
Yes. Okay.
Yeah.
But those are ones I can pick from to show you.
Yes.
Okay. All right. I'm gonna pick 5 because it's got a lot going on in it, if that's okay.
For sure.
All right. The derivative f prime of x has this this notation: limit as h goes to 0, f of x plus h minus f of x all over h. This problem
Yes.
is kind of like this. Sometimes you see in books, they shortcut to this. They say f prime of a is the limit as h goes to 0, f of x, I'm sorry, a plus h minus f of a all over h. They're both correct. The first one gives you the derivative of f of x, and then you have to put the number in. The second one over here gives you the derivative at that number, but not the function. So like, do you know which one you're going to want to do here?
I usually use the one on the left just in case the denominator equals that to 0 somehow, because she usually has, yeah.
Okay,
Yeah.
so there's two pieces here. The first one, the number 2, you already have. You already have the original function. That's no big deal.
Mhm.
What you're looking for is f of x plus h, and you have to find that. So that means you have to put,
Yeah, yeah. You add h to wherever there's an x. Yeah,
yes, and
I remember.
this is the these are very tedious to do, but because you have to expand these things. So you want to get really fast at this. It might be good to like shortcut what this x plus h squared is. It's x squared plus 2xh plus h squared,
Mhm.
and then 4x plus 4h plus 2. So one more line here: 3x squared plus 6xh plus 3h squared plus 4x plus 4h plus 2.
I need to be more careful about expanding because all of most of my mistakes happen from stupid like expanding errors.
Yes, yes, you're going to be very, very, very careful with that. So this limit here, this f of x plus h is all this stuff we just found. So I know you don't have this on a test, but you can just copy and paste, and there it is. So then you're subtracting f of x. This is another place where mistakes are made. So f of x is, in parentheses, 3x squared plus 4x plus 2 all over h.
Yes.
Okay, so it's very important here that you remember this negative goes to everything, and I'll explain a self check here shortly. Hopefully it was covered in class, but lots of writing. Even I don't think these are very fun because there's lots of writing. Okay, when you get to this step, the next line here, if you have done this correctly, this is very important. If you've done this correctly, everything in the top should have an h in it. Okay, so see how this minus 3x squared cancels with that on the left.
Mhm.
Minus 4x cancels with minus 4x. Minus 2 cancels with 2. So
Oh,
everything
that's
that's left over, and this is by design, but nobody seems to ever say this. Everything in the numerator should still have an h in it
that's
because
awesome.
you're going to divide by h. So,
Wow.
you divide every single one by h, and you get 6x plus 3h plus 4. And now we get to talk about, do you know how to take a limit? Do you understand the mechanics of it? I don't know. I don't think you need to know what a limit actually is at this point, but do you know what to do to get a thing out of this?
You just plug 0 in, right? And then you're like,
For
oh,
h
f
though,
times x.
not for
Right.
x. In this case, h. So this is 6x plus 3 times 0 plus 4. So this equals 6x plus 4. And we said all the way in the beginning, this is what you get is the derivative. F prime of x is 6x plus 4.
Awesome.
Okay, but we're
Okay.
not done. We're
Yes.
not done. We're this is like, you get
A.
80%.
We have to find A,
Right,
right?
right. That's right. So you have to do it -1. 6 times -1 plus 4 equals -2. So if you do it this way, you get the function, put the number in. As I was trying to mention here at the top, if you use this one on the right, you would have gotten -2 out from it at the end.
Oh, yeah. Normally she wants us to find the like other thing first, and then because normally she asks it like, oh, what is the derivative of this? And then what is it when it's this?
Yes.
Yeah.
Okay. So we did the sort of the longest one. Um, 6. I'll just make a note here. Um, you for you. Sorry, these things are. I don't know why this is moving around so much. So if you have x plus h cubed, this is x plus h times x plus h times x plus h.
Mhm.
Make sure you do it this way. You FOIL and then multiply.
Right.
Very easy to get that wrong. You don't do that. Okay. Where should we go from here for what to cover next?
Um,
Because we can do one of these, but it's exactly the same way, and I'm happy to go through it. But you have to tell me if you want us to do that.
can we do some Riemann sums?
Yes. Okay, let me go back to that document that you shared with me, and we'll see if I can make some sense of. You said Riemann sums, section 10.2. 10.2.
That's 10.2 in our pre-calc textbook, but she gave us this study guide and all these problems from her calc textbook, so it might be different.
Yeah. I'm not sure which one she's referring to here.
Let's see. Page. Okay, so Riemann sums. Okay, let's see. Oh, it's on page 297, I think.
Okay. Like 13 through 20.
Yes, I believe so. Let's see, 297. She's she
Or 4, 5, or 3, 4, 5.
she just put 296, 297, and 298, and didn't specify which problems. So, you know.
Real helpful. Okay.
And then she said specifically to try a word problem.
This would be so much easier if they just told you it was on the test.
I really, yeah.
Because I'm guessing too. I have no idea. I can't get inside the thinking of your instructor. Okay. So I think like what I want to do is cover the mechanics of this, like how to do it, not try to explain what it is that we're doing. But your teacher tends to, from what I understand, to emphasize the like not just what you're doing, but why you're doing it or what it means. And I mean
Mhm.
that's a little bit of a reach here. So let me draw.
It's okay. I'm
So
better at learning the why on my own than the how.
okay, okay. So
Yeah.
there's 1, 2, 3, 4, and 5. rectangles here, but those are incorrect. So that's like the first like mistake you may think, oh gosh, what are those? You actually have 1, 2, 3, 4, 5, 6 numbers if you look at this. So L5 is actually the one you do first. We're gonna do 5 here. L5 uses 1 through 5. So we kind of like look at this part of the data set. R5 uses 2 through 6, which is a little weird, but that's the nature of this thing. So basically, left excludes the rightmost value, right excludes the leftmost value. So your sum, whether it's R or L, is always delta x times, and then you evaluate at each point. And this is where the notation, I don't want to get too crazy notation, but it's like x0 plus f of x1 plus so on until you get to the end. So seeing it's usually easiest to do. So delta x is b minus a over n. Okay, and you get that from kind of your endpoints here. You're doing this from 0 to 1, so 1 minus 0 over, and your n is 5. So this becomes 0.2.
5 for x.
Sorry, so
yeah.
And you'll notice the difference between these is 0.2.
Okay.
So that's also kind of
okay. That makes sense.
So your left 5, we're going to do your left 5 is 0.2 times f of x naught. So basically it's the y value. 50 plus 48 plus 46 plus 44 plus 42, and you get a number out of that. That's your left sum.
Because you're finding the like area, and that's just area of a bunch of rectangles. Okay.
Yes, that's exactly right. Okay, your right sum is very similar. It's delta x 0.2. The way I would show you in the classroom is that to see the overlap here, is that they overlap here in the middle, but you have one on the right, one on the left, and that's the difference between these.
And then so you always have to take it the one step further, and then you just find the average between the two.
That's kind of her own thing. That's not really correct, but that's fine.
Okay.
Sorry, I shouldn't. Okay, so the 6 would be very similar. Like you could do 6 on your own if you wanted at some point, but it's this, and then it's this, and your delta x, when you calculate your delta x, it's b minus a over n. You get 3 minus 0 over 1, 2, 3, 4, 5, 6 again. So it ends up being 0.5. It just so happens that that is the same width here. Now on the AP, I know we're getting way ahead of ourselves. The AP, they use actually different widths on these, which we'll talk about if we do a lesson next year towards the AP. But they do.
I am definitely not taking calc next year, so that's lovely.
Yeah. Well, you're saving yourself some pain.
Oh yeah. Yeah.
Okay.
I'm taking AP stats instead. I think I'll enjoy it a lot more.
All right, so now we should maybe look at a 7, or we can go to 13 through 20, 13 through 18. Would any of they're kind of the same in terms of like, they're just slightly different. Let me just grab one from 13 through 20.
Okay.
All right, so let's do, I like lefts, so we're gonna do the left one there. All right, so you're gonna do this one. Your f of x is the square root of 6x plus 2, and your 1 comma 3, that's your a, and that's your b. Your n, you have to be given n. Your n is this value down here, the 6, the subscript. You have to be given that. If you're not given it, you need to ask for it, because you can't do it without it. And that's sometimes it's encoded in here, so you have to be very, very careful. So the first thing you do is you find delta. Delta x is b minus a over n, 3 minus 1 over 6. So you get 1/3. Okay. So the reason we're doing it this way, because it's a little bit, this one's a little bit difficult. So what I like to do is I like to make a list. We start at 1, but I'm not going to call it 1. I'm going to call it 3 over 3 because we're going to add this 1/3 each time. So that's 4/3, 5/3, 6/3, 7/3, 8/3, and 9/3.
Okay.
So these are like your x values. You need your f of x values, which you don't have. So you get those by putting these fractions back into the original there. Okay. So I'll do this first one's really 1, so it's the square root of 6 times 1 plus 2, and you get a number for that.
Okay.
Okay. So your left sum, your left 6 here is delta x, which is 1/3 times, and this is where I made the notation make more sense. It's f of 1, because that's 3 over 3. Maybe do it that way. 3 over 3 plus f of 4/3 plus f of 5/3 plus f of 6/3 plus f of 7/3 plus f of 8/3. So you need these values in here.
Okay.
So you can either calculate them and then write them out. If you don't get a calculator, you'll get something nice you can evaluate. This one doesn't evaluate nicely, but these are numbers.
Okay.
And you add them up and
Seems
multiply it. So that's the
good.
difference. In the first examples we did, they gave you the numbers in the table. In the second example, you have to calculate the numbers in the table, both the x and the y. And hopefully it's clear that we're stepping by delta x each time.
Mhm. Yeah, that checks out. That makes sense.
Okay. What else would you like to have us look at today?
Do you think you can give me a brief rundown of how in inverse, like how to, let's say I have cosine of x, y equals cosine of x, and I want to isolate x. How would I do that? I kind of don't know how inverse trig functions work.
Like this. So this is like okay. So the one I'm gonna just make sure I understand the proper context, because sometimes you're asked like you're asked to find the cosine inverse of 1/2. Is that more what you're asking about, or solving for x using inverse trig functions?
Solving for it using inverse.
Okay. Yeah. So the like in short here, you can apply cosine inverse to both sides of the equation to undo cosine. And
Okay.
this on the right undoes x. There's a bit of like, if you could see my hand, there's like this hand waving where you're distracted because this only works from 0 to pi,
Oh, interesting.
which is like, it's like, oh yeah, like don't worry about that, but it really is important because this thing is only good from 0 to pi, and you have to know that. But you can always undo.
That's why they're like for a given value between
Yeah.
0 and pi. Okay, it makes so much more sense.
Yes. So just
Okay.
if I said y equals tangent x, the final answer is x equals tan inverse or arctangent of y, and that's kind of a standard thing.
Okay. Okay, yeah. So I've always seen it like the intermediate step skips, and I just don't think I ever really got that.
Exactly. It's just like go here and you don't know why. So hopefully that's clear. It's very similar to like if I said tell you like log base 3 of x equals 2. The intermediate step is to
That's
write
what I was
this.
about to ask about.
Yeah, it's just like this. And what most people just write is, oh, x equals, well, 9. And you're like, how did, I don't know. But this is what's happening.
Okay.
When you're,
Can we
go,
briefly go over log rules, perhaps?
sure. Let's
Okay.
say, and let's say x equals log of 3t, and we want to
Mhm.
solve for t.
Okay.
I just made this up. There's other better examples, but we're going to review that the log of a times b becomes the log of a plus the log of b. So this is
Oh,
x equals log 3 plus log t. Okay, so
okay.
you can subtract this from both sides. You can x minus log 3 equals log t. And then do you know how to undo log? It's kind of what we just talked about a little bit. Actually, let me put a squared there. So we'll put a squared there, squared there. So now another property here is if you have log x to the n, this equals n log x. Basically, the n comes out in front. This exponent, whatever it is, comes out in front. So this on the becomes 2 log t. That 2 comes out in front of me. That's
Okay.
okay. So we can divide both sides by 2. And we have x minus log 3 over 2 equals log t. You can undo, and that's what we were just showing you. You show this because the base is 10. It's not written. 10 log t is 10 to the x minus log 3 over 2. And that's what undoes the log here. This is how this becomes t. So t is this 10 to the x minus log
Okay.
3 of 2. So now let's say back up here, I told you that y is log of I don't know, log of t to the 4th. Okay, so we're gonna use that now. So we have t. T is right here. So let's put that into this thing. But first, let's bring the 4 out in front. So it's 4 log t. That's using that property again. We bring those up back and forth, and then we're going to substitute all of this in for t. So it's y equals 4 log 10 to the power of x minus log 3 over 2. There's really a 10
Okay.
here, but this is an exponent, so the exponent comes out in front. So y equals 4 times x minus log 3 over 2 log base 10 of 10. Here's another property. If you have log base b of b, this always equals 1. So since that's 10, the base is 10, since that's 10, that equals 1. So this whole thing is 1. And this becomes y equals
Okay.
4 times x minus log 3 over 2. 4 and 2 divides, this becomes 2 times x minus log 3. And, kind of done there. But that's essentially what some properties of logs that you might see.
Okay. I I think I'm gonna write a log cheat sheet on one of my 2 sheets.
Okay.
Just
Keep in
in
mind, a lot of these are cheat sheets already out there. So I would pull from one of those, and I assume you got to handwrite it. Like I would go find one on the internet and just pull the ones you think are helpful for you.
Oh, no, I've taken, screenshots and then I make the font really
Oh,
small and
great.
then I put it yeah, no, it's totally allowed to be printed.
Oh,
It's kind
cool.
of beautiful.
Okay, that's
Yeah.
great. That's very very good of you. I'm glad you're thinking that. 'Cause some students don't know that stuff. And got to be creative.
Oh, no. Oh, no. Oh, no. Yeah. Okay, that makes a lot of sense, thank you. So, like, log if like, what does log actually mean? Like, what
What is a log? Uh,
Yeah.
well, it's they're they're very archaic. They were used before calculators were more prominent to like display pieces of information on scales. They're not especially
Oh,
useful, but they undo exponential functions. So e to the x is undone by ln of x, and then like 2 to the x is undone by log base 2 of x. But if you look at any time series data, and This is in science, obviously. So the best example is like the stock market. Anything with times, if you look at a log of the time scale, you can see trends. So if you look at the stock market, it looks like this. Okay, and if you look at it in a log scale, though, it will have a every unit of time is as a power of 10. So if this is 10 days, then this is 100 days. This is 1,000 days.
Okay. I probably should have known this before I took my AP Chem test today.
Maybe.
But,
So it's a way to show like more rapid successions of data. They're not really useful anymore. I mean, I'm trying really hard. They're not all that useful. But if you take some sciences in college, or maybe at your school, they sometimes want you to do things like graph T and then the log ln of F, like for force, something like that. And what they're hoping is you'll see a linear trend.
that looks like rate law.
What's that?
That looks like a rate law for AP Chem.
Yeah. Oh yeah. Yeah, exactly. The rate laws are logarithmic. Yeah, that's good. Good. I don't care for chemistry much, but yeah, that's exactly what they are. So that's it. There's not anything more. I mean, yeah. Okay. So what? Go ahead.
Is it like division is to multiplication?
You can't, what I was trying to point out, and that's kind of what I think you're asking, is you can't have E without ln, because you need it's very much like x squared goes with square root of x. Like you have to have the ability to undo something.
Okay, nice.
And the if you want to get like a little bit deeper, there really is no such thing as E. It's just an infinite polynomial, which you'll see in calculus too, if you ever take that. Yeah. But the point is like these are just shorthand. It's like saying pi is the ratio of the circumference to diameter. It's a lot easier to write pi than this every time. It's easier to write e to the x. You'll forget this, but e to the x is 1 plus x squared, 1 plus x squared plus x cubed plus x to the fourth plus forever. That's what e to the x is. And so this is just a way of saying no, we're gonna just there's some other things I missed on here, but there's some the point is like a lot of math is really just something new. It looks new, but it's really something you already know. It's in a different format. That
people just get lazy and want to write it shorter.
Well, yeah. It's lies to write e to the x than all this. Infinite. You can't write an infinite polynomial because you'll never finish. So,
yeah.
Thank you for allowing me to do a little extra kind of stuff here at the end. It's I rarely get to do that. I usually just have to stick to the lessons, but it's nice to do some of this and show you some things.
Yeah, it's interesting to learn about. It makes math a lot more fun than just processes.
Yeah. Okay, so we're going to end here. If you that you scheduled for tomorrow, I would just recommend either going through the questions and saying like, let's do these, or just if we could focus it as much as possible. That's the best way to help you for the upcoming exam.
Yes. I think I'll do a couple of each on my own and then see what I can't do.
Great. Well, thank you for scheduling, and I'll see you next time.
Thank you so much.
You're welcome. Bye now.